Alright, a particle moves according to these parametrics. For what value is the particle closest? That's kind of the first hint here, the first thing that leads you to the steps necessary to complete this. So we're trying to find a value of the particle, or a t-value, that gets us closest to the point 20. First thing we need to do is take these parametrics and write an equation with it. So my equation is given, or I'm sorry, the slope of my equation is given by essentially the coefficients of t. So remember, this is my y. So this goes on the top. This explains how high or low I go, how far up or down. So my slope of my line is going to be 4 over the coefficient of t in the x component of the parametric, which is -2. So that tells me that my slope is -2 overall. We also want, we also have to run it through a point, and the point that's given here is, here's the x and here's the y. So my equation that's given by this parametric is y minus y1, so plus 6 equals -2, x minus 3. So there's my equation given by this parametric. So the next thing that we're interested in is this closest part. So closest meaning perpendicular. Has to be the perpendicular in order to be closest, and it also runs through point 20. So if this is step 1, then step 2 is to find the perpendicular line that runs through 20. So perpendicular to this means that the slope is negative, or I'm sorry, the opposite reciprocal. So the slope of my perpendicular is now going to be 1/2, and it runs through the point 20. So again, y minus y1, that's 0, so that's nice and easy, equals the slope times x minus x1. So this is the equation that is perpendicular to this line and runs through 20. So this is the second part. So I now have two equations. They want to know the t-value here. So before I get the t, I've got to figure out an x or a y that corresponds. So how far over or how far up am I in order to find the intersection of these two? So that's the next step, is I'm gonna use substitution. So I have a y value here. I'm going to plug that y value up into the other equation to figure out where these two lines are intersecting. So let's go ahead and do that. So 1/2 x minus 2, and then I've got a plus 6 here. So I'm just plugging this value into y. It's equal to -2 x minus 3. Go ahead and expand, or you can multiply by 2. That might be a little bit easier. If I multiply by 2, then this becomes a 1, and I'm just left with x minus 2. The 6 multiplied by 2. So again, I'm just trying to multiply this by 2 to get rid of the fractions. 6 multiplied by 2 is 12. That's equal to -4 times that quantity. So simplify. We've got, this is going to be a -4x plus 12. That's equal to x plus 10. Move your stuff around. Looks like it's going to be a 5x equals 2. So x equals 2/5. So I just found the x coordinate of where these two lines are going to intersect, these two. And I only need an x, because remember, what I want to know is for what value is it closest. Well, I just need a t. So I have two equations actually for t. I have an x equals this 3 minus 2t. So in order to figure out t, I just got to plug this x back in to that equation, to the end of that parametric. So I know that x is equal to 3 minus 2t. It's given by that parametric up top. Plug our x in, so that's 2/5 equals 3 minus 2t. Minus 3, so technically that's a minus 15/5. Gives you a -13/5 equals -2t. Divide by -2, divide by -2 is going to end up giving you 13/10 for your t-value. This is the t-value that is closest to this point.